Hi friends, in this video we are going to discuss about effect of supply voltage on torque slip speed characteristics. Effect of supply voltage on torque slip speed characteristics with full load torque constant and V by F not is equals to constant. V by F not is equals to constant. V by F not is equals to constant and full load torque constant. Effect of supply voltage on this torque characteristics. Let's see how the characteristics will change by changing the supply voltage. Right? Let's see. First of all, full load torque constant. What is full load torque formula? Approximated full load torque formula kV square into S by R2. This should be constant. This should be constant. Tell me. Which are constant already? Here K already constant. Yes. Rotor resistance also constant. Here we are just changing the supply voltage. So supply voltage is not constant and slip also not constant. Tell me what is the condition to get full load torque constant? Yes? What is the answer? Yes, the combination of V square and S should be constant. Right, sir. V square into S should be constant. S into V square should be constant. S into V square should be constant, nothing but S is inversely proportional to V square. S is inversely proportional to V square. This is very important one. S is inversely proportional to V square. Yeah. For example, if voltage reduces, then slip increases. If slip increases, the rotor speed reduces. We can control the speed. Yes, sir. We can control the speed. Second one, if voltage increases, slip reduces. If slip reduces, speed increases. Yes, we can control the speed. This is the speed control method, first of all. Yes, sir, I control the speed. What are the advantages? What are the advantages? Tell me what are the advantages? One is we can control the speed. We can control the speed without extra losses. Without extra losses, we can control the speed. Without extra losses, we can control the speed. Second advantage applicable for this method applicable for slip ring and squirrel cage induction machine. We can control speeds of both motors, slip ring motor and squirrel cage motor. So applicable for slip ring and squirrel cage induction motors. Slip ring and squirrel cage induction motors. Yes, sir. Slip ring and squirrel cage induction motor. We can control the speed without extra losses and applicable for both slip ring and squirrel cage induction motors. Very good, sir. What are the disadvantages? Can you tell me what are the disadvantages? If voltage reduces, we can reduce the speed. Yes, right? See clearly, voltage reduces, speed reduces. For example, actually my voltage is 400 volts per machine. Now I am reduced to 200 volts. If voltage reduced to half, then speed reduces some range. Yes, sir, we can control speed, no problem. Now, in second way, now I want to increase my speed. How can I increase my speed? How it is possible? By increasing the voltage, we can increase the speed, sir. Nothing but if the voltage is 200 volts, actually the rated voltage of the induction motor is 200 volts, then we have to increase the voltage from 200 to 400. If voltage increased from 200 to 400, we can increase the speed of the machine, of course. But the rating of the motor is 200 volts actually. The rating of the motor is 200 volts actually. For that motor, if you apply 400 volts, what happened? Actually, the rating of the motor is 200 volts, but now you are applying 400 volts. What will happen? Sir, nothing happens, sir. New machine will comes in the place of old machine. Yes or no? New machine will comes in the place of old machine because actually rating is 200 volts, but you are applying 400 volts. The insulation gets damages and machine gets short circuited. Total machine gets collapsed. Machine gets damaged. So don't increase the voltage. We can reduce the voltage, no problem, but don't increase the voltage. If voltage increases, insulation damages, short circuits may take place, machine gets damaged. That's why the above rated speeds not possible. Only applicable for below rated speeds. Only applicable for below rated speeds. Only applicable for below rated speeds. It is not applicable for above rated speeds. It is not applicable for above rated speeds. This is the disadvantage. Right? Now let's see here about torque. How we can control the torque. See here, torque. First of all, starting torque is equals to formula kV square into R2 by X2 square. If voltage reduces, starting torque also reduces. The next one, maximum torque is equals to kV square by 2x2. If voltage reduces, maximum torque also reduces. If voltage reduces, maximum torque also reduces. And next one, slip at maximum torque is equals to R2 by X2. Tell me, if voltage increases, what happened to slip at maximum torque? Slip at maximum torque is equals to constant because this is independent of voltage. Independent of voltage. This is independent of voltage. Sorry, here the SMT we can't change. We can change starting torque and maximum torque, but slip at maximum torque won't changes. Now let's see the characteristics, how they will affect it. Let's see, this is generally at normal voltage V. At normal voltage V, maximum torque, starting torque, slip at maximum torque. If voltage reduces, starting torque also reduces. And maximum torque also reduces. Nothing but maximum torque will take place. For example, here my maximum torque takes place here. And there is no changes in slip at maximum torque. Always maximum torque occurs at this slip only. So this is my maximum torque and this is my starting torque. Now the curves are like this. This is reduced voltage. This is normal voltage and this is reduced voltage. For example, actually not possible. For example, voltage increases. If voltage increases, starting torque also increases. If voltage increases, maximum torque also increases. But there is no changes in slip at maximum torque. There is no changes in SMT. So maximum torque occurs here. So the curves are like this. This is increased voltage, normal voltage, reduced voltage. If voltage increases, curves moves upside. If voltage reduces, curves moves downside. If voltage increases, if voltage decreases. This is the effect of supply voltage on speed and torque as well as slip. There is no changes in slip. They are asking question like that. There is no changes in slip at maximum torque, but actually the slip changes. But there is no changes in slip at maximum torque. Be careful. Slip depends on voltage, but Slip at maximum torque independent of voltage. Don't confuse, please. Slip depends on voltage, but slip at maximum torque independent of voltage. Yes, this is about the slip. The effect of supply voltage on torque slip speed characteristics. V by F naught is equals to constant and full load torque is constant. Once C total. And next one, effect of supply voltage with V by F constant. This is very important. V by F constant. The second concept is V by F naught is equals to constant. Now the third concept is V by F is constant. And full load torque again constant. Take the full load torque formula. Full load torque is equals to K V square into S by R2. This should be constant. This should be constant. But actually, this is already constant. We are not changing the rotor resistance. Just we changing the voltage. Because effect of supply voltage, right? Now tell me, K is constant or not constant? Tell me. Yeah, K is constant, sir. Is it constant? No, sir, K not constant, sir, here. Because generally we know K is equals to 3 by omega. 3 by omega nothing but 3 by 2 pi ns. Nothing but 3 by 2 pi 120 f by p. Nothing but K is nothing but 1 by f. K is not constant. When V by F constant in this condition, K is not constant. K, in terms of K, in the place of K, we have 1 by F. Because generally we know during the torque equation, K is equals to 3 by omega. 3 by 2 pi ns. Ns is equals to 120 F by P. This is very important, sir. Right? This is important. K is directly proportional to 1 by F or inversely proportional to F. Inversely proportional to F. Right, sir. So now the full load torque is directly proportional to R2 already constant. Now K is nothing but 1 by F and V square nothing but V into V and into S. This is K 1 by F, V square V into V and S. This is already constant because we said already V by F ratio constant. So now tell me, to get full load torque constant, what is the condition? V into S should be constant. Nothing but the slip is inversely proportional to voltage. Slip is inversely proportional to voltage. In the second concept, slip is inversely proportional to voltage square. But here, slip is inversely proportional to voltage. If voltage reduces, slip increases, then speed reduces. If voltage increases, then slip reduces, then speed increases. In this case, we can reduce the voltage as well as we can increase the voltage. Both are possible because we are already maintaining V by F ratio constant. That's why both are possible. Voltage reduces as well as increases. Both are possible in this machine. What are the advantages of this machine or this method? What are the advantages of this method? Advantages of this method. This is applicable for slip ring and squirrel cage induction machine. Applicable for both. And this is applicable for above rated and below rated speeds. Above rated and below rated speeds. Applicable for both. Above rated and below rated. Applicable for both slip ring and squirrel cage induction machines. And no extra resistance. That's why no extra losses. These are the general advantages. All are the advantages only. There is no any disadvantages actually. There is no any disadvantages actually. These are the advantages. Applicable for both slip ring and squirrel cage induction machine. Applicable for both above rated and below rated speeds. Right, sir. This is the speed control. Now speed control completed. Now for torque control. See here, torque control. Right, sir. See, first of all, the starting torque is equals to K into V square into R2 by X2 square. Generally, here R is constant, but the starting torque is directly proportional to K, nothing but 1 by F. And here we have V square, and here we have F square. Why it is F square, sir? Generally, X is the reactance. X is equals to, what is the formula? 2 pi F L. X is equals to 2 pi F L, F square. The reactance contains one frequency. Reactance is square. That's why frequency is square. Frequency is square. Right, sir. And this is already constant. Now this is. See here, V square by F square is already constant. V square by F square already constant. So tell me, the starting torque is inversely proportional to F. But we require that in terms of voltage. Yes or no? Effect of supply voltage, right? We are telling that effect of supply voltage. That's why there is no voltage terms. For voltage terms, I am doing that multiplied and divided by voltage. Multiplied and divided by voltage. Multiplied and divided by voltage. Then again V by F constant. Again V by F constant. Finally, the starting torque is inversely proportional to V. See how it is tricky. If voltage reduces, starting torque increases. See how it is. If voltage reduces, starting torque increases. But whereas in second concept, if voltage reduces, starting torque reduces. But in third concept, in V by F constant, if voltage reduces, starting torque increases. Starting torque increases. Right? And next one, what about maximum torque? Maximum torque is equals to, what is the formula? KV square by 2x2. Here 2 already constant value, it is a constant. And K nothing but 1 by F. V square nothing but V into V. V square nothing but V into V. K nothing but 1 by F. Reactance X nothing but F. Reactance X nothing but F. So V by F constant and V by F constant. Finally, the maximum torque is constant. Starting torque is inversely proportional to voltage, but maximum torque is independent of voltage. If voltage increases or decreases, there is no changes in maximum torque. Right, sir. Starting torque completed, maximum torque completed, and next one, yeah, slip at maximum torque. Slip at maximum torque is equals to R2 by X2. Here R2 already constant, so X2 nothing but 1 by F, but there is no V. We should have the relations in terms of voltage. That's why multiplied and divided by voltage, these two gets a constant. So the slip at maximum torque is directly proportional to 1 by V or inversely proportional to V. If voltage reduces, the slip at maximum torque increases. If voltage reduces, slip at maximum torque increases. If voltage increases, slip at maximum torque reduces. These are the 3 points. Starting torque, maximum torque, slip at maximum torque. Let's draw the diagram. The characteristics. How the characteristics will affect. Let's see here the characteristics. Let's see here the characteristics. See here, the characteristics. For example, here NR is equals to 0, S is equals to 1. Here NR is equals to NS, S is equals to 0. Right? Next, normally the characteristics are like this. Normally the characteristics are like this. Generally, here we have a maximum torque, and here we have a slip at maximum torque, and here maximum torque, and here starting torque. This is at normal voltage V. If voltage reduces, starting torque increases. If voltage reduces, SMT increases. If voltage changes, there is no changes in maximum torque. Now tell me, if voltage reduces, starting torque increases. If voltage reduces, starting torque increases. If voltage reduces, maximum torque increases. Slip at maximum torque increases. Nothing but we have to get maximum torque at this slip. And there is no change in maximum torque. The maximum torque is constant, always constant. Right? How it is? The curve is like this. This is voltage reduced. And here, generally the people doing the common mistake. Generally, the curve just comes to here and putting here. Generally, the people. But that is not exactly correct answer. If we draw 100% correct answer, generally I told you voltage and frequency should be constant. V by F ratio constant. I told you that. And here I told you voltage reduces. If voltage reduces, starting torque increases, SMT increases. Okay. If voltage reduces, to get the constant V by F, what about frequency? For example, initially my voltage is 400 volts and frequency is 50 hertz. My ratio is 8. But now my voltage reduced to 200 volts. But this V by F ratio should be constant. To get the same ratio, same 8, what is the frequency we have to take? The frequency we have to take here 25 hertz. Then only we can get 8. Nothing but frequency also reduces. If voltage reduces, frequency also reduces, then only we can get constant value. If voltage increases, frequency also increases, then only we can get the constant ratio. For example, voltage increased to 400 from 200. I want 8 ratio. Then what is the frequency I have to take? 50 hertz. Nothing but if voltage increases, the frequency should be increases. Okay, sir, whatever. If voltage reduces, frequency also reduces. If frequency reduces, synchronous speed Ns is equals to 120 F by P. If frequency reduces, synchronous speed also reduces. If frequency reduces, synchronous speed also reduces. So here the curve comes to here. This is the another synchronous speed because synchronous speed reduces. Right? For example, if voltage increases, starting torque reduces. Slip at maximum torque also reduces. And maximum torque occurs as this condition. And the curve is like this actually. This is increased voltage. Yeah, of course, increased voltage. But what is the curve ending point? If a voltage increases, frequency also increases. If a frequency increases, If voltage increases, frequency also increases. If frequency increases, the synchronous speed also increases. Synchronous speed also increases. This is my another synchronous speed. Don't forget these values. In V by F changing method, the synchronous speed also changes. Right? But in second concept, don't worry about frequency. In second concept, don't worry about frequency because here V by F not equals constant, I told you in second concept. That's why don't go for frequency. Only voltage is the responsible parameter. But here voltage and frequency both are responsible parameters because V by F we have to maintain constant. Right. This is the characteristics. Now they are asking the effect of supply voltage on torque slip speed characteristics with V by F constant is similar to. Tell me, is similar to? Is similar to. See once. Is similar to effect of rotor resistance. Yes or no? In effect of rotor resistance also we have the same characteristics. And in effect of V by F ratio constant also we have the same characteristics. Both are same, sir. But in effect of rotor resistance we have a more losses. But there is no losses. There is no extra losses. There we have a more extra losses. And effect of rotor resistance only applicable for slip ring induction machine. This is applicable for both slip ring and squirrel cage. And effect of rotor resistance only applicable for below rated speeds. But this is applicable for above rated speeds as well as below rated speeds. So this is the most preferable speed control and torque control method in our induction machine. This is the most preferable speed control and torque control method in our induction machine. It's the very important. And finally, they may ask the question on this. They may ask the question on this. Here, slip is inversely proportional to voltage. Slip is inversely proportional to voltage. Okay, these are the effect of supply voltage on torque slip speed characteristics with V by F constant with full load torque constant. One see clearly, this is very important.